Hi and welcome. Today we look at another investment decision rule, namely the internal rate of return. So we're focusing here on different investment decision methods. So we had looked at the NPV last time, and this time we're going to look at the internal rate of return. So what is then the internal rate of return? Okay, so we looked at NPV last time, and then we looked at, for example, this example and said we could look at if this investment, is it profitable at, let's say, 5%. Last time we did 10%, but now we could look at it with 5% cost of capital. Okay, so maybe it is, maybe it isn't. But what happens if the cost of capital is 10%? Well, then last time we saw that it's not profitable. But what happens if it's 15%? Then maybe it's even less profitable, or you would have higher, lower negative NPV. So it matters actually what the actual interest rate or the cost of capital is. And that's exactly what this internal rate of return is all about. So here's a table which shows that at a discount rate of 0%, which means we would have no time value money, then the NPV of this project would be 100. Last time we looked at what if the interest rate is 10%, we found that it was negative NPV. Okay, but what happens if it's 5%? Well, then it's suddenly positive. So somewhere here between 5 and 10%, there should be like a break-even point when it suddenly becomes profitable to make this investment. So normally we have something like this. We have a graph. So on this axis we measure the NPV, and here we have the discount rate or the cost of capital. And usually this is how most investments look like. When you have a low cost of capital, then investment is very profitable, and then as the interest rate increases, the NPV goes down, and at some point it becomes negative. So around here it's not really worth undertaking the investment anymore. So then you can find, or I did it this time, that at 9.3% exactly, with that interest rate, then the NPV is equal to 0. Okay, and we call this the IRR. So the point, the interest rate, which in this case was 9.3%, the interest rate where NPV is equal to 0 is called the investment's internal rate of return, or IRR. Okay, so then you might want to ask another question. So here we have the same investment. How high could the cost of capital be before the investment is no longer profitable? I mean, that would be a reasonable question to ask. Maybe I think that my cost of capital is 7%, but I'm not really sure. Maybe it's actually 10% or maybe it's 4%. So there's a little bit of uncertainty. And then it could be good to know how high can this cost of capital be before my investment is no longer profitable. So let's say I had a range here between 4 and 10%. And if it's profitable up to 10%, well, it doesn't really matter what my cost of capital is. It's still profitable to do it. So then we should do it. Okay, so then like formal definition, the internal rate of return, IRR, is the discount rate that makes the NPV equal to 0. And you can a little bit informal say that it's the return of the investment. It's the internal rate of return. So it's already in the name. Okay, then how is the decision rule made? Well, if the IRR is higher than the cost of capital, then you should invest. Okay? If the IRR is less than the cost of capital, then you should not invest. So what does this mean then? Well, the cost of capital, it says that, okay, we require at least 10% return on our investments. If the IRR is higher, it means that the investment has a higher return than 10%. So let's say that investment is a 15% return. Well, that's better than just 10%, so we should do it. And in the other way, if the internal rate of return is 5%, it means that we get a 5% return on the investment, and that's not as good as the 10% we require. And we can also see that in this picture then. So here is the internal rate of return. And we saw that at higher values, so in this area here, when the cost of capital is low, so let's take 5%, then the NPV is fairly high. And the higher it gets, the lower the NPV gets. So the higher the discount rate, the lower NPV. And for example, here at 15, we have a fairly big negative NPV. And we can use this IRR as a cutoff point. So if the cost of capital is lower on the left-hand side, then it's a good investment. If it's higher than the cost of capital, so IRR is higher, then it's obviously a bad investment. Okay, and now we're going to look at the disadvantages with this method. First of all, the internal rate of return cannot be used to compare projects. It's really easy to think that, well, I should take the one with the highest return, right? But it's actually not so simple because, as we said last time, we should use the net present value to compare projects with the same lifetime. Okay, so here are two projects with the same lifetime. Let's say that my cost of capital is only 3%. It's very low, but let's just take 3% here. Then it turns out that investment A, the blue one, is the one that is better because the net present value here is almost 60, whereas for the investment B it's maybe 45 or something like that. But on the other hand, at 12%, for example, if that's my cost of capital, then investment B is suddenly better than investment A. So then, yeah, I have very straight lines when I draw, I see. But anyway, you can probably see that the blue line is below the red line. So at this area here, basically from somewhere here up until both are negative, then it's better to do investment B than to do investment A. But if the cost of capital is lower than, yeah, let's say this is roughly 8%. So in this area, then investment A is the better one. And for that reason, we cannot simply say that just because B has a higher IRR, it's here, compared to that one for A, it's not enough to say that B is better than A. It depends on what the cost of capital is for the firm. And therefore, we cannot use IRR to rank projects to say which one is better than the other. And also, it could be so that multiple IRR exists. So usually when you say you want to find the IRR, well, what do you do in a case like this? You have one IRR here, and you have another IRR there. It's not too easy to say what is the investment's return, because here it would be very hard to distinguish between which one is the real one. Well, you can't say. So then it's very hard to say, okay, what if my cost of capital is 19%? Should I do the investment or not? Just based on the IRR, it could be a yes or a no, depending on which one you find. But when you look at the NPV, it's quite clear that yes, you should do the investment. So also here, NPV is much better. The decision rule is sometimes reversed because you could have investment with cash inflows late and cash inflows early and cash outflows late. So it looks something like this. And what do we do then? Well, if we have a low cost of capital here, then the IRR is higher, and the decision rule said that we should invest, but in fact we have a negative NPV. But instead, if we have a high cost of capital, so it's higher than the IRR, then the decision rule said it's a bad investment, don't do it. But in fact, we have a positive NPV. So it's not always so easy to just use the IRR to decide. And it might also be the case that it doesn't even exist. In some cases, all investments are bad. It doesn't matter what cost of capital you have. It's simply not a good idea to take 100,000 kronor and burn it. Regardless of the interest rate, it's still a bad idea. In the other case, there are some investment which is always good. So it doesn't really matter what your cost of capital is because you get your money back so fast, it doesn't really matter. So it could look, for example, like this. Here you have a positive NPV, whatever the interest rate is. Or it could be that it's always a bad idea to do the investment, regardless of the interest rate. And if you try to find the IRR here, you will try forever because it simply doesn't exist. So now we talked about quite a lot of disadvantages. So why should we use IRR at all? There are some reasons to use IRR. It might not be the best decision rule on its own, but the information you get from the value of IRR is valuable. So remember what we said in the beginning. Maybe we're a little bit uncertain of what our cost of capital actually is. Well, then the IRR gives us like a margin. Let's say that we have a cost of capital of 8% and the internal rate of return of this investment is 15. It means that we had to be very, very wrong about what our cost of capital is in order to make a bad decision here. But on the other hand, if the IRR is very close to our cost of capital, so we have a cost of capital of 8 and the internal rate of return is maybe 8.3%, then if we're really uncertain about the cost of capital, we might make a bad investment because it should be negative when we see it as positive if we're wrong. So it gives us an idea of how sensitive our analysis is to the interest rate. Um, and if we take the method in itself, it accounts for the time value of money, since we use an interest rate. It considers all cash flows involved in the project. And as I said, it gives you an idea of how sensitive your NPV calculation is. And also, it might be fairly intuitive. So, since it almost corresponds to the return that you get on investment, it's very easy to explain to someone, okay, but how much money do we make on this investment? Well, it's a 20% return. It might be more easy to understand than if you say, well, if we compare it to the present value of everything, then we make something corresponding to an extra $100 today. People might not understand that, but percentage usually is quite easy for people to follow. And also it's used for other purposes, which I'm not going to cover now, but you can use it to compute yields on bonds, and you can also use it to find like an actual loan rate when you include all costs. Okay, so let's take one final example. We have a project with the following estimated cash flows. So in today, we have a cost of 100. In 1 year's time, we receive 35. In 2 years' time, we receive 40. And in 3 years' time, we receive 60. What is the project's IRR? And we should answer in whole percentage points. So it's very important to remember that when you're doing it by hand and not using a computer, you won't get an exact answer. But you could say that it's 15 and not 14, for example. That's possible, and that's what we're going to do now. Okay, so as always, we draw a timeline because it's easier to see how it works then. And here we need to move all of these cash flows to today because we wish to compute the NPV of this investment. Okay, so as a start, let's use an interest rate of 10%. I have no idea why I chose 10%. You just have to choose something. You can roll a dice if you want. It doesn't really matter. We will still find out the IRR eventually, and I'll show you how. Okay, so to compute the NPV then, we said last time that we should subtract the initial outlay. Then we add the first year cash flow, which was 35, divided by 1 plus the interest rate, which was 10%, to the power of 1, because it's 1 year. Then we add the second year cash flow, 40, divided by 1 plus 0.10 to the power of 2. And then we add the last year's cash flow, 60, divided by 1 plus 0.10 to the power of 3. Okay, if we compute this, we find that the NPV equals to 9.95. Okay, so what did that tell us? Well, remember this picture? It says that we have a positive NPV, so we're somewhere in this area. Okay, so maybe we're here. This is NPV equal 9.95, and this is then 10%. It means that the IRR are higher than 10% because it should be to the right, so it should be a higher interest rate. Okay, so that means we should guess on a higher interest rate. How high should it be? 15, 20, I don't know. But take something. In this case, I'm going to guess on 15% just to see what happens. We do the same thing. We compute the NPV. So minus 100 plus 35 divided by 1 plus 0.15 to the power 1 plus 40 divided by 1 plus 0.15 to the power of 2 plus 60 divided by 1 plus 0.15 to the power of 3. Okay, if I compute this, I find that the NPV is now only 0.13. So again, we're looking for the interest rate where NPV is equal to 0. We're not going to find it exactly, but we want to know, is it 15% or 16%? But the important thing here is NPV is positive. This is still greater than 0. So that means that IRR is higher than 15%. How much higher? Well, I don't know, but what I do know is, in the last slide, we found that with 10%, the IRR was 9.95. With 15, it's only 0.13, so it's probably quite close to 15%. But I can't yet tell if it's 15 or 16%, or maybe even 17. But it feels reasonable to assume that it's quite close to 15. So what I'm going to do now is that I'm going to guess on 15.5%. Okay, why 15.5? That seems completely, unnatural. Why not 16%, for example? Well, the reason is, if I'm going to round it to a whole percentage point, then let's say that IRR is equal to 15.4%. What would that mean? Well, it would mean that with 15.5%, NPV would be negative, and at 15.4%, this would be rounded to approximately 15, because if it's 0.4, you round it down. If it's 15.3%, I would also round it to 15. And on the other hand, if I find that NPV is positive here, so IRR is actually bigger, then if it's, for example, 15.6%, then I would round it to 16. So the reason I'm not choosing 16% is because I think I'm close to the solution, and I think that it's 15%, but I want to be absolutely certain, which is why I test like in the middle between 15 and 16. If it's lower than 15.5, I would always round it down to 15, because I already know it's between 15 and, it's larger than 15%. Okay, so I do it the same way as I did last time, and now I find that NPV is negative. So this means that I know that the IRR is larger than 15%. I found that last time, and since the NPV is negative now, I also know that it's smaller than 15.5%. So what it actually is, I have no idea. It could be 15.4. It could be 15.3, 5, 6, 7, 8, whatever. It doesn't really matter. What's important is whatever it is, I will round it down to 15%. And since I only need to find it in whole integers, I'm done here. Okay, so to summarize what I've said now, it's usually impossible to find exact internal rate of return. Okay, if you use a computer, of course it can help you, but if you're using a calculator or just your hand like you're going to do in your exam, then it's really, really hard. So instead, you get close enough until you feel like you're done. And I call this clever guessing. So what do you mean by clever guessing? Well, I'm a mathematician, so clever means that you're being systematic. You're doing it in a way that makes sense, that will eventually get you to the solution. Okay, so let's assume that we start guessing on 15% here. Okay, so we're going to start at 15%. What happens then? Well, we guess at 15%, so that was our guess. And we find that NPV is negative, so it's less than 0. What does that mean? Well, it means that the IRR must be to the left. So we should guess on a smaller interest rate. How much smaller? Doesn't really matter. We could take, for example, 5%. Okay, what happens at 5%? Well, we look. Then we get a positive NPV, so NPV is greater than 0. If NPV is greater than 0, well, then we should guess on a higher interest rate, because it should be to the right of 5%. Okay, so what we've done now is we said that it can't be higher than 15, and it can't be lower than 5. So all of these areas are gone. What should we guess at now? I don't know, maybe 10% seems reasonable, because it's been between these two. So we take 10%, and we find that IRR is NPV is actually negative. So it's the actual IRR is smaller than 10%, but we also find that NPV is quite close to 0. So compared to the other two, which were like minus 50 and almost plus 50, this is very, very small. So it makes sense that it's close to 10%, but it is smaller, that we can see here. So now maybe a good guess would be 9% or 8%, but maybe not exactly in the middle between 5 and 10, but let's say we take 8%, which is around here. Then we find NPV to be positive, and we would go further to the right, maybe take 9%. And we would do this to make the interval smaller and smaller and smaller, until eventually we're close enough so that we can feel certain that now I know with the precision I want, it could be whole percentage like in my example, or with 1 decimal point, that in this interval I know it will always be rounded to 15.1%, for example. And that's what I mean by clever guessing. You don't just roll a dice every time, but you actually see, okay, NPV is negative, let's take a smaller one and make an interval, go down to 5. Then it's positive, okay, and it's almost as positive as it was negative, let's take in the middle. And then you guess this way to eventually reach your conclusion. Okay, so how do we find it then? Well, as I said, we start by making a guess on the interest rate. Then we compute NPV for this interest rate, and if NPV is larger than 0, we guess on a higher interest rate. If it's less than 0, we guess on a lower interest rate. But now, it's really, really important to stress that, remember that we showed all these cases when I said that IRR is not good. We could have an opposite looking NPV, sorry, it would be like this for you, or we could have multiple IRRs and so. So this method only works when the NPV structure is downward sloping like this. And that happens when you have the negative outflows early and the positive cash flows later on. So if it doesn't look like that, it's not certain that it will work like this. So it's worth remembering that maybe this decision rule or way of guessing it might be different in other cases. Okay, so just to sum it up, last time we looked at NPV, where we calculated, and we did a lot of NPV today as well, and we said that investment is profitable if NPV is greater than 0. Today we looked at the internal rate of return, which is the discount rate that makes NPV equal to 0, and again, D might be no one or several. And as a decision rule, we said that if the cost of capital is smaller than internal rate of return, then we should do the investment, assuming that the investment looks like normal, this NPV scheme. Otherwise, it would be something else. Okay, so that's it for this video. Thank you very much.